Okay, so this is kind of like crude oily questions, plastic questions that could potentially come up for Unit 1. So the first question says, state what is meant by hydrocarbon. It is a compound, make sure you use that word, that contains only hydrogen and carbon. Describe how crude oil is formed. Dead marine plants and animals, intense heat and pressure over millions of years. Okay, there's lots to remember there, but you have to remember that exact definition. Okay, state the two fractions which are not used as fuels. Napar and bitumen are not used as fuels. So different fractions not used as fuels would be bitumen and napar. Okay, calculate percentage of diesel present in crude oil. This was quite a difficult question. Okay, so all of this together added up to 200, they told you. First off, you had to work out what diesel was. So you had to add these all up and then do 200 to take away all these, and you've got 44. Okay, then to work out the percentage, you do 44 divided by 200 and then times it by 100, and that would give you 22%. Okay, looking at this question then, name the process by which large hydrocarbon molecules can be made into smaller molecules. That is cracking. And then small unreacted molecules can be joined together to produce long chains. That's polymerization. Okay, I'm going to leave this 6 marker out because I don't think it's going to come up in that form. Next question then, looking at different types of plastics. This says polyethylene is used to make carrier bags and bin liners. What are the properties on the table would be the best as to why it's been chosen? Okay, I would have put waterproof because it can be carried in all weathers. And then polystyrene used for disposable cups. It's non-toxic, so you can put drinks in them, so you're not going to get anything when you have your drink. State why you use plastics to cause environmental problems and give one way of overcoming them. They fill up landfills. Okay, plastics take millions of years to disintegrate, absolutely ages. Okay, and for that reason, once they go in a landfill, they fill them up. Also, if we burn them, which people have tried, they do release toxic gases. So there's 2 big ways that plastics kind of ruin the environment. The big way we overcome that is recycling. Recycling still does have a cost, but it does limit the amount of plastic that's been wasted. Then looking at the next question, you had to give a name for the molecule that is. So that's methane, because that's the first in the hydrocarbon chain. You had to then count the carbons, 1, 2, 3, and then count how many hydrogens. So C3, 1, 2, 3, 4, 5, 6, 7, 8, H8. And then with this one, you had to draw it out. Okay, and it just follows the same structure with the carbons in the middle. Remember, carbon always bonds 4 times, hydrogen bonds once. Again, the same kind of question. State how crude oil is formed. Crude oil is formed from the dead marine plants and animals. Intense heat and pressure over millions of years. Okay. State what must happen to the crude oil before it enters the fractional distillation column. So crude oil is obviously a liquid that we can mine out. When it gets here, we need to turn it into a gas. Okay, the reason for that then is it's able to rise to whatever point it needs to, because hot air, hot gases rise. Okay. State the property of hydrocarbons which allows them to be separated using this method. That's different boiling points. Again, the same question. What is meant by a hydrocarbon? A compound. It has to be a compound, okay, containing only hydrogen and carbon. State why the fractions obtained are not single compounds. This is because different carbon chain lengths will come off each fraction. So if you actually looked at the information, carbon lengths 1 to 4 are all in that fraction. Carbon lengths 5 to 10 are all in that fraction. So that means that there will be different things coming out. So there'll be some things that are carbon 1, some things that are carbon 2, some things that are carbon 3, and some things that are carbon 4. So they'll all come out in the same fraction there right at the top. Most fractions are used as fuel, however, some are converted into small reactive molecules via cracking. So that's how you make long chain hydrocarbons into shorter chain ones. Name the process used to produce small reactive molecules, that's monomers, and then they join all together to make polymers. Okay, if you were making a polymer, then this ethane molecule would look like this. Okay, to have the double bond removed so it can join with other monomers to make a long chain polymer. One disadvantage of use of plastics such as polyethylene: fill up landfills millions of years to decompose. Moving on then to looking at reactivity. Okay, reactivity of different compounds. Okay, so magnesium plus copper sulfate. That you can see that a reaction has taken place. So what's happened is the magnesium has stolen the copper away. Okay, so you end up with magnesium sulfate plus copper. Okay, which tells us that magnesium is more reactive than copper. Okay, so that's why I've put a little box around it there. Okay, same thing then, you can kind of see here is if there's a reaction, then that means that whichever one is on its own is stealing away that sulfate. So again, zinc is more reactive than copper. So you straight away should be able to put copper at the bottom. Okay, then this is our big one here, magnesium and zinc. What's happened there? Again, a reaction has taken place because you can see it. So it becomes magnesium sulfate, which means magnesium is more reactive than zinc. So that's how we put them in a table. Okay, I've then written this out, the reaction between magnesium and copper sulfate. Okay, it would be copper plus magnesium sulfate, which I've also written at the top. Give the chemical formula for zinc sulfate. Again, it's a top swap drop situation. Can you see how that comes up quite a lot? Okay, their charges are exactly the same, so it would just be ZnSO4. Okay, balance the equation. Just looking at this, okay, I've got 2 oxygens on this side. Okay, so it means I need 2 oxygens on this side, so I have to put a 2 by there. Okay, that then gives me 2 leads, so I have to have 2 leads. Okay, if in doubt, put 2s, please. Okay, state what is meant by oxidization. Oxidization is when something gains oxygen. So the carbon has no oxygen on this side and ends up with 2 oxygens on this side. So the carbon has been oxidized because it gains oxygen. Okay. State why heating carbon cannot be used to extract aluminium. Carbon is less reactive than aluminium. Okay. Give the electron structure of sodium. Sodium has got 11 electrons, so 2 go in the first shell, 8 go in the second shell, 1 goes in the final shell. Be careful of that question. It's a nice, easy question. You just write it out with little commas in the middle. Sodium reacts vigorously with water. Give 2 observations. You would see fizzing, you would see hydrogen gas being given off, you would see a yellow flame, and it would turn into a ball. The products would be sodium hydroxide and hydrogen. The difference would be if you had potassium, it would give you a lilac flame, and there's likely to be an explosion. We're not doing that question. Okay, so this question then is looking at what goes into the blast furnace and what it's used for. So iron ore is iron oxide, where we extract the iron. Coke is a source of carbon and is used as a fuel, and limestone is used to remove impurities. Okay, bit of a more complicated balancing equation, but you could get 1 mark for looking at that and seeing that there were 2 ions on this side, so I need 2 ions on this side. Okay, 4 oxygens on this side, 2 on this side, so it becomes a little bit more difficult. But if you times them both by 3, you end up with 6 on this side and 6 on this side. Okay, iron oxide is being reduced. What does that mean? The loss of oxygen. Okay, so these are electrolysis questions. Okay, it is quite hard, but we are going to have a little look. Okay, so an ion is anything with a charge. Okay, so with this, we've done aluminium. You could have put O2 minus, okay, as long as it had charge, okay. An atom then is an element on its own, okay, so no number. And then a molecule is 2 of the same element, chemically bonded. Okay. Give a reason for which electrode aluminium is formed at. Okay, so when you think about things like this, you want to write the panic anagram. You're going to do positive anode, negative is cathode. And that means that aluminium will go towards the cathode, which is negative, because its opposites attract. Using the information in the diagram above, give the chemical name and formula of aluminium, okay? Alumina. So alumina is formed from these 2 elements, okay? So that's aluminium oxide again. We're going to do top, swap, drop, aluminium 3, O2. Swap them, aluminium 2, O3, drop them, aluminium 2, O3. Okay. State 1 problem associated with electrolysis, the production of CO2, global warming. Give a different property of aluminium, and one of the uses relies on it. Low density, it's used in planes and plane wings. Okay, same kind of thing here. Identify the electrode. That's the thing that you're trying to split up using electrolysis. This would be copper sulfate. Give the name of the positive. Okay, and you can remember that using the rhyme. Panic. Positive is anode. Okay, so that would be anode. The initial mass is always 0.2 grams, and then you had to work out how much it formed. So you did 21 take away 20.2, and that would have given you 0.8. Then went on to plot the graph, okay. It says draw a suitable line. Be really careful of this because this one is a curve, okay. So be careful because even when they say suitable line, they could mean curve. Use the graph to find what would happen after 30 minutes. So 30 is between 20 and 40. Draw a line across, and that gives you 0.64. Window frames are made from many materials, including aluminium and iron. Give one property that makes aluminium better than iron. Okay, aluminium is resistant to corrosion, it will not rust. Which negative ion? So again, it's aluminium. Okay, you've got molten aluminium oxide. Go on your table of ions, have a look. It would be like that. It's attracted to the negative. Which negative ion, is attracted to the positive electrode? That would be oxygen, 2-. Give the word equation for what's happening. Aluminium oxide is splitting up into aluminium and oxygen. The temperature of the cell is 1000. The melting point of aluminium, so at 660 degrees it melts, okay? They haven't given a boiling point, so we don't know when it turns into a gas, okay? So we're going to assume that at this point, because it's 1000, it's still a liquid. Give the main reason why this process is expensive. The ridiculously high temperatures. That is a really extreme high temperature to make. So a lot of electricity is used, okay? Final question, why must they be molten? Ions must be free to move. If they're solid, they're fixed, they can't move, okay? Nice, easy question here. Putting 2's in front to balance it out because you had 2 there. State in terms of electrons, what happens to the lead ions, okay? So they gain electrons, okay? You can see here, these ones are losing electrons, the other ones have to gain. Describe what you expect to happen at the formation of the cathode. You would see lead form. Why does it still remain lit? Electrons still form and allow electrons to flow. Okay, so the kind of process will happen because electrons will flow a little bit longer.